Hello, I am Kiran Kumar from Nature of Physics. Today topic is reference circle from the simple harmonic motion. First I am going to explain the displacement, vertical direction and also velocity and acceleration and equation of simple harmonic motion with time period with clear explanation with neat diagrams. Okay students, so next video I will do based on the horizontal motion. So same reference circle, this is vertical motion. So in this I am going to consider there is a particle of mass m which is moving in anti-clockwise direction with angular velocity omega. Okay, so it reached this y point, its time period is t by 4 and it is moving upward direction from mean position to extreme position. See, blue line is representing clearly. Next, here the particle is moving from y to x dash, so that a pink color represented there. So when the particle is moving on the circumference of the circle, it is doing simple harmonic motion on the y dash diameter. Okay, so that moving from y to x dash, it is moving on the diameter y dash from extreme position to mean position. And next one from the x dash to y dash, so that the particle is moving, the time taken is, we can write 3t by 4. Okay, and next here the particle from mean position to extreme position on the diameter. And next the particle is moving from the y dash to x, so total time taken is t, and it is moving from extreme position to mean position. Mean position is y is equal 0, extreme position is plus a, so that is positive y axis, minus a, negative y axis. See student, clear diagram and explanation given. When the particle is moving on the circumference of the circle in anti-clockwise with angular velocity omega, it is doing simple harmonic motion on y dash diameter. Okay, so for example here the particle is reached at a point P after the time t. Okay, so that I can write here a is the radius of the reference circle and the particle is moving with uniform speed, angular speed omega, so that it is making an angle theta at the mean position, so that opposite angles are same. So I can write here omega is the angular velocity, omega which is equal to theta by t, and angular displacement theta is equal to omega t. Okay student, so that next I am going to find the vertical displacement. After that velocity and acceleration with graphs we will discuss. Okay, so now displacement purpose I am considering first one triangle. The triangle is O, the center is represent O, P, this is normal is representing N letter, O, P, N. Okay, so for this sin theta which is equal to opposite is y and hypotenuse is a, so that I got y which is equal to a sin theta, but theta is equal to omega t, so that I can write here y which is equal to a sin omega t. Okay, and this is taken as equation number 1. So in this equation we can find the mean position displacement and extreme position displacement with respect to angular displacement theta also. Okay, so wait a second there. Now continuation derivation. In this first I am going to write about the mean position. Okay, mean position. Mean position y is equal to 0, so that here y is equal 0, replacing 0 is equal to a sin omega t, so 0 into anything 0, so I am getting sin omega t which is equal to 0, that is omega t which is equal to 0. See there, sin 0 is equal to 0, that I can write theta is equal to 0. So mean position I got here y is equal 0 and angular displacement also 0, given tick mark clearly about the mean position. Next we are going to discuss about the extreme position. Okay, for the extreme position, see there, here this is the plus a amplitude. Here particle is moving on the circumference of the circle, so equivalent diagram is represented. This is 0, this time is t divided by 4, this time is t divided by 2, this is 3t by 4, and this is time t. So time taken to complete one rotation is equal time taken to complete one oscillation on the vertical diameter. Okay, so time period is t, clearly represented. Okay, and also phase we can represent here. So phase representation is like this. This is pi by 2, this is phase represent pi 180 degrees, this is 3 pi by 2, and this is phase representing 2 pi student 360 degrees. Okay, and then continuation derivation I'm going to explain about the extreme position. See there, extreme position, y is equal to a. Okay, plus or minus we can write. Okay, and next equation is replacing this value is replacing in equation 1, that is a is equal to a sin omega t. So a get cancel, sin omega t is equal to 1. I am getting omega t which is equal to 90 degrees, sin 90 is equal to 1, so that is theta is equal to 90 degrees at the extreme position. Extreme position theta is equal to 90 degrees and linear displacement y is equal to a. So this is the clear information about the phase diagram for the displacement. What type of displacement this? Vertical displacement, horizontal displacement I will do in the next video, and I will provide the link in the description in this video. Okay student, and then velocity I am going to write there. For this velocity, the basic definition, the rate of change of displacement is called velocity. Okay, so the velocity v which is equal to d by dt of y, writing where y is a sin omega t is replacing, so that v which is equal to d by dt of a sin omega t. Okay, next equation, velocity v which is equal to a common sin omega t become cos omega t, and differentiation with respect to time only, but their omega t is there, omega is common. This is I am writing as equation number 2a. So first equation for the velocity v which is equal to a omega cos omega t, and next we are going to write second velocity with respect to linear displacement equation. So this is angular displacement equation, so that next equation, that is cos omega t. So v which is equal to a omega cos omega t is root over 1 minus sin square omega t there. Okay, so again using the equation number 1, from this equation number 1, we will get y divided by a which is equal to sin omega t. The value is replacing there, v which is equal to a omega root over 1 minus y square divided by a square. Okay, and LCM, after that we will get velocity second equation, a omega root over a square minus y square divided by a square, square root of cancel, a and a also get cancel. So velocity second equation, v which is equal to omega root over a square minus y square. This I can write as equation number 2b. Velocity second equation I got. See, they are clearly explaining, student. First we got the displacement equation in the simple harmonic motion, and second we got the velocity two equations. Okay, first equation is v is equal to a omega cos omega t, second equation v is equal to omega root over a square minus y square, and then continuation we will discuss the mean position and also extreme positions. Okay, so that first one discussing about the mean position. For the mean position, here two values we can consider, theta value we can consider, and also y is equal we can consider. So that first I am writing y is equal to 0. So y is equal to 0, replacing in this equation v, which is equal to omega root over a square minus 0 square. Second equation using, because of linear displacement and linear velocity, v is equal to here square root of cancel for the a, and we got velocity is maximum, v max is equal to a omega. See, maximum velocity is equal to a omega we got at the mean position. At continuation I am going to find their mean position with respect to first equation, so that theta is equal to how much there, 0 degrees, and the equation is v, which is equal to a omega cos omega t. Omega t is equal to 0, cos 0 is equal to 1, so that I am getting their velocity v, which is equal to a omega. Velocity is maximum at the mean position. Okay, see there, velocity is maximum I got at mean position in both conditions. Okay, one is taken as linear displacement and another one is taken as angular displacement. Theta is equal to omega t, clearly given. Wait a second please. Yes, now continuation, velocity we got at the mean position. Next I am going to discuss about the extreme position. Okay, extreme position. So for extreme position here, x is equal, y writing, y is equal to plus a, and theta is equal to 90 degrees. So the basic equation for this, velocity v is equal to extreme position omega root over a square minus y square, so that y value is replacing, that is root over a square minus a square, get cancel. Velocity is minimum at the extreme position. Okay, and second condition also considering here. See there, in the second condition theta is equal 90 degrees taken. Second equation, velocity v, which is equal to a omega cos omega t. Theta is equal 90, nothing but omega t also 90 degrees, so that velocity which is equal to a omega into cos 90. Cos 90 is equal to 0, 0 into anything is 0, so that velocity again we are getting 0. Both comparison clearly explanation is giving to you students. Okay, so that extreme position is completed. And next one we will have the acceleration. So the rate of change of velocity is called acceleration, and before going to that, here the graph is represented. This is the velocity and time graph. So time on the x-axis and velocity on the y-axis representing, so that here mean position velocity is this is the graph, mean position represented origin, and here mean position velocity is maximum plus a omega. Okay, and next one here negative value represented velocity, and next here the particle is moving like this. T is equal t divided by 4, here t is equal to t divided by 2, here t is equal to 3t by 4, and this is t representing. And phase also we can represent clearly here student. The phase representing, this is pi by 2, and this is representing pi, this is 3 pi by 2, and this is 2 pi phase. Okay, whenever displacement is maximum, okay, at the extreme position velocity is equal to 0. Whenever displacement is 0, so that velocity is maximum. Once again repeating, okay na? So that next acceleration I am going to write. So before that another graph is there. Here velocity is represented on the y-axis, so this velocity is a omega, okay, on the displacement is y is equal to plus a, clearly represented. On the y-axis is velocity, on the x-axis is displacement y, okay. And next one, acceleration is there. So the acceleration, the rate of change of velocity is called acceleration. So a which is equal to dv by dt, so that a which is equal to d by dt of velocity is equal to a omega cos omega t. And next step, a which is equal to a omega common, and differentiation of cos omega t become sin omega t, and differentiation of sin omega t become minus sin omega t. Again omega is common because of we are doing differentiation with respect to time only. Second time omega is constant, so that the equation of acceleration which is equal to a is equal to minus common a into omega omega square and sin omega t. From the equation number 1, that is y which is equal to a sin omega t is replaced in this equation, equation number 3a. So that the acceleration equation a which is equal to minus omega square a sin omega t is written as y. This is I can write as equation number 3b. So equation 3b represents simple harmonic motion equation. What is that? Simple harmonic motion. Simple harmonic motion, nothing but a particle is moving along the circumference. It is doing simple harmonic motion on any diameter. Here the particle is moving on the circumference of the circle, but it is doing simple harmonic motion on y dash diameter. Okay, so that a body is said to be to and fro along the straight line about the mean position, such that at any point its acceleration is directly proportional to the displacement in magnitude and opposite in direction. A body is said to be to and fro along the straight line about the mean position, such that at any point its acceleration is directly proportional to the displacement y and opposite in direction. This represents the simple harmonic motion. Okay students, so we got the simple harmonic motion equation there, that is a directly proportional to the minus y, a directly proportional to minus y. Okay, now I can write this is equation number 4. Okay, and continuation. Next, here also we have to do the equations for the mean position and also extreme position, student. So this is I can write a 3a equation and 3b equation, and after that mean position, extreme positions I want to represent for the acceleration. So that first here I am going to write about the mean position. Mean position y is equal to 0, so that a is equal to minus omega square y. So y value is replacing, so that a is equal to minus omega square into z 0. Minimum acceleration is possible at the mean position. Mean position velocity is maximum and acceleration is minimum. Okay student, and then I can represent at the extreme position. So extreme position theta is equal to 0. Sorry, here first mean position two values we want to represent. One is, okay, so no space, we can do it. Here I can write mean position second condition, sorry for the mistake. So that theta is equal to 0, angular displacement writing. Okay, that is equal to omega t. Okay, and equation using this, a which is equal to minus a omega square sine 0. Okay, so mean position theta is equal 0, sine 0 is equal 0, 0 into anything 0, so that I am getting minus a omega square into 0. So acceleration is minimum, which is equal to 0. We are doing with the two values, student. Okay, mean position and also extreme position. See there, notice that point. Okay, now here I did mistake there. Theta is equal to 90 degrees. I can modify this. Theta is equal to 90 degrees, and I can write y is equal to plus or minus a. So simply writing a. Okay, and replacing the values. Yes, first y equation, that is acceleration a which is equal to minus omega square, y value is replacing as a. Simply I got acceleration is maximum at the extreme position. Acceleration is maximum at the extreme position. And second also I can give clarity here, so that theta 90, here sine 90 is equal to 1, so that acceleration which is equal to minus a omega square sine 90 degrees, so that a which is equal to minus a omega square sine 90 is 1. A is maximum at the extreme position, that is minus a omega square. Okay, so here also I got acceleration is maximum at the extreme position and acceleration is minimum at the mean position. In two conditions, clear explanation we did. Yes, student. And then next one, we will have the equations for this. Before the equation of motion, and before that there is a graph for the acceleration and time graph. On the x-axis I am considering, okay, acceleration on the y-axis, and on the x-axis is time representing there clearly. Okay, and the particle is moving like this. Okay, and this is the maximum acceleration is a omega square, clearly given, plus or minus this minus a omega square, negative y-axis, because of on the y-axis acceleration taken. Okay, and this is the time t by 4, and this is the time t divided by 2, this is the time 3t by 4, and this is the time capital T, time period. Okay, so that here the graph is quite opposite comparing to the displacement and also acceleration. See, so displacement is positive, acceleration is negative. Both are equal in magnitude and opposite in direction. Okay, students. And then continuation, next we will have equation, that is time period equation is there. I want to do here time period. Okay now, student. Okay, see there, for this time period I am writing equation number 3b. From equation number 3b, a which is equal to minus omega square y. Okay na, and then here omega minus represent opposite direction. Okay, and a divided by y which is equal to omega square, and omega which is equal to root over a divided by y. Okay, student, and omega which is equal to 2 pi by omega angular velocity which is equal to 2 pi divided by capital T, angular velocity omega. So that 2 pi by t which is equal to root over a divided by y. Okay, and next equation, cross multiplication is there. Okay, that is 2 pi root over y by a which is equal to capital T, clearly represented for time period equation t, which is equal to pi root over y divided by a. Okay, and next equation is, that is, we will discuss about the equation of simple harmonic motion. Equation of simple harmonic motion. Here also I am using from equation number same only, that is 3b. Okay, that equation is here, yes, a is equal to minus omega square into y, but a which is equal to d square y by dt square. Okay, and replacing there we will get d square y by dt square, okay, which is equal to minus omega square into y. And last equation, this d square y by dt square plus omega square y, which is equal to 0. This equation I can write as equation number time period equation continuation. This is fifth one, and this is equation number 6. Okay, and then continuation, last step, just positions I am going to discuss here. 1 second. Here students, see there, representing positions, mean position and also extreme position. Wait a second please, I will give clarity. Horizontal axis, and this is the vertical axis. Okay, and then continuation here, mean position, and this is the extreme position, and this is also extreme position. Okay, and next representing here mean position, here y is equal to 0. Okay, and extreme position, here y is equal to plus a, here y which is equal to minus a. Okay student, and next representing there, that is acceleration is maximum. Okay, that is a omega square. Okay, a is equal to, next here acceleration a is equal to minus a omega square, negative value, positive value, because of this is positive y axis, this is negative y axis, this is positive x axis, negative x axis, and this is representing positive y and this is representing negative y. Student, O is the origin O. Okay, and at mean position velocity is maximum, V max is equal to a omega. Okay, plus or minus we can write. Okay, and then here potential energy is equal to 0. At the mean position potential energy is 0. At extreme position potential energy is maximum. Here I can write potential energy is maximum, potential energy maximum. Okay, because of displacement is maximum. Here kinetic energy maximum, the reason is, what is that, velocity is maximum. So this is the clear information when the particle is moving with angular velocity omega in anti-clockwise direction. Please do like and subscribe our channel.